I'm going to be teaching lesson 8.5, which is about products with radicals. Now this lesson has to do with the root of a product theorem, which states that the quantity of x times y to the 1/nth power equals x to the 1/nth times y to the 1/nth. This can be rewritten as the nth root of x times y is equal to the nth root of x times the nth root of y. Now it can be rewritten like this because any number raised to a fraction, like 1/3, is equal to that number under a radical with the denominator of that fraction as the radical. So x to the 1/3 equals the third root of x. This is a pretty simple concept, but it can be used to solve complex problems like the fifth root of 8x to the 4th times the fifth root of 4x to the 6th. The first step in simplifying this is to combine like terms under one radical. So you would get 32x to the 10th under the fifth root. So then you would split apart the numbers and the x's. So you would have the fifth root of 32 times the fifth root of x to the 10th. Now you can easily solve both parts to get 2, which is the fifth root of 32, and x squared, which is the fifth root of x to the 10th. And before we move on, I want you to see that multiplying radicals is as easy as 1, 2, 3. 1, you combine like terms. So in this case, you would combine the x's and the numbers. 2, you split apart the combined numbers and the x's. And 3, you simplify. You can also simplify radicals like the square root of 72 by finding factors. So 72 is not a perfect square, but some factors like 9 and 36 are. So you have 9 times 8 and 36 times 2. You want to use 36 times 2 since 36 is a larger perfect square, so you'll have a more simplified answer. So the square root of 72 can be rewritten as 36 times 2. Now, to get 36 out of the radical, you need to find the square root of it, which is 6. So your final answer would be 6 times the square root of 2. Simplification is also as easy as 1, 2, 3. 1, you find factors of the number under the radical, and one of the factors has to be a perfect square. 2, you put those factors under the radical, and 3, you take the perfect square out of the radical by finding the square root of it.